7.5 to 7.7 discuss the trig functions. We really thoroughly talked about sine, cosine, which I forgot my E, and the tangent. The sine, cosine, and tangent are all ratios. We're going to be referring to a specific angle, right? They will be looking at one of the angles, and they are ratios of different sides. So the sine was the opposite, so you'd look at across the triangle, opposite over the hypotenuse. The cosine was the adjacent side over the hypotenuse, and the tangent was the opposite over the adjacent. So you need to make sure that you are looking at your angle and you're figuring out which side is opposite, adjacent, and identify your hypotenuse as well. That being said, you need to fill in your parts. Sometimes you are given both legs, sometimes you are given one leg and then the angle, and sometimes you're given the angle and the leg in the denominator instead of the numerator. So you're going to have to be able to do different things and solve an entire triangle, finding 3 angles and 3 sides. So that leaves us with our lovely abbreviation of SOHCAHTOA. SOHCAHTOA. Sine is the opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. If you can remember SOHCAHTOA, you should be able to set all 3 of these up and their inverses as well. Keep in mind that sine inverse, cosine inverse, and the tangent inverse, when we use these, we are given both of these side lengths. So we'll be putting in a fraction or a decimal of some point, and our answer will result in a degrees, all right, an angle with degrees. Okay, so with these we can solve for sides, and with these we can solve for angles. Let's move on to some examples real quick. Okay, so what if I said find the sine of angle A and find the cosine of angle A, or find the tangent of angle A? I could have chosen angle A or angle B. The sine is the opposite over the hypotenuse, so that is 12 over 15, and that would reduce to 4 over 5. If I said to give me the fraction, this is what you would give me. And if I also said, please reduce and give me the decimal to the 10th, let's say to the 10th, you would give me 0.8. The cosine is the adjacent over the hypotenuse, 9 over 15. That's 3 over 5, or 0.6. And the tangent is the opposite over adjacent, so that would be 12 over 9, 4 over 3, which that one would actually have to round. It would be 1.33333 continued, and that would round to 1.3. So you need to be able to set up, reduce, and give me both fractions and decimals. For an example like this, you need to look at the angle that you have and the sides that you have and what kind of trig function you can use. So here I am given the hypotenuse. So that means that I can either use SO or CA because I'm given the hypotenuse. With TOA, I'm unable to use the hypotenuse, so that would leave me with 2 unknowns. So let's just use sine because it is first. Whoa, hit the zoom. Okay, so if I use sine, the sine of 40 degrees, I do not have that opposite side, so that is what I would label as x, and I would put an 8 in order to solve. I'm currently dividing by 8, so I'd need to multiply by 8. So that leaves me with x equals 8 times the sine of 40 degrees. And you would input that into your calculator and get that side. to equal about 5.1. Let's say we're rounding to the 10th. That would give me 5.1. Alright, all of that being said, you should be able to set something like this up and solve for a side. And then we're going to need to also use our inverse functions as well in order to solve for the angle. So let's look at a full example. For the next two examples, let's solve the triangle. So we're going to need to find FE. We're going to need to find FE as well as these two angles. Once you find one of the angles, you can easily find the second one by subtracting from 90. So let's find FE. You guys love to use the Pythagorean theorem, so let's start there. So let's label that side A. We're going to have a squared plus 3 squared equals 9 squared. So that means a squared plus 9 equals 81. A squared, subtract 9 from both sides. You're left with 72. Take the square root of both sides. Square root of 72. And let's go ahead and round to the 10th. It's going to be about 8.5. So this side is about 8.5. Alright, I've got 3 sides. Now let's go ahead and find one of the angles. Let's start with angle F. Alright, if I have all 3 of the sides, that means that I can use any 2 of them and then use an inverse function. Let's just use sine. I like sine. So the sine of angle F, I will go ahead and tell you that if you use the 2 sides that are given to you in the problem and not your rounded answer, you will come out to a more exact solution for that angle. Alright, I will have a little bit of leeway with rounding depending on the way you went about it. So the sine of angle F is 3/9 or 1/3. So that means the inverse sine of 1/3 should give me the measurement of angle F. And if I input that into my calculator correctly, that should give me 19.5 degrees. Well, if I have this angle, I can take that away from 90 because angle F and angle D should add up to 90 degrees. So 90 minus 19.5, you will result in 70.5 degrees. So I have 3 angles, 19.5, 90, 70.5, and 3 sides as well. So I solved my triangle. For this triangle, you're going to have to do something a little bit different. You're going to be doing things in a little bit of a reverse order. Well, I already have this angle, so let me go ahead and take that away from 90. That means this angle is 25 degrees. Alright, and I can set up any of the trig functions almost. I need to realize what side I have. So let me pick an angle. Let's talk about angle Q. Alright, I have the adjacent angle. So SOHCAHTOA. Alright, I have the adjacent angle. So that means I can use my cosine to find my hypotenuse or my tangent to find the opposite. Alright, I cannot use sine of that angle. So let's go ahead and set up the tangent. Let's set up the tangent. The tangent of 65 degrees, you need to make sure you're using the proper angle, is the side opposite. I don't know the side opposite. Let me just label these 2 sides differently. Side opposite over adjacent. Well, I might as well label this the H with this being an O for opposite. Alright, the side O over 10. Well, how do I solve? Multiply each side by 10. Call it a day. Alright, my opposite side is 10 times tangent of 65. And if I type that into my calculator absolutely correctly, that means that PN should be about 21.4. And you can either use the Pythagorean theorem from there, with 10 squared plus 21.4 squared equals your hypotenuse, or c squared, which that means you would be using a rounded value, so I don't suggest going about it that way. Let's instead use cosine. The cosine of 65 degrees is equal to 10 over the hypotenuse. In order to solve for h, let's get it out of the denominator. So we're going to multiply each side by h. Those will cancel out. H times cosine of 65 equals 10. And I need to divide by cosine of 65 degrees to get it on the other side. So your h is equal to 10 divided by the cosine of 65. And that will give you about 23.7. 23.7. And just for fun, I may ask you, alright, you've solved the triangle. Good job, you've solved the triangle. What's the perimeter of the triangle? Perimeter. You add up all the sides. 10 plus 21.4 plus 23.7. If you line those up vertically or you type them into your calculator, you should end up somewhere around 55.1. Well, what if I then continue and decide to be nice cruel and ask you for the area? Well, I know area is 1/2 base times height, and my base is 21.4, and my height is 10. Well, let me go ahead and 1/2 of 21. 1/2 of 21 is 10.5, and 1/2 of 0.4 is 0.2. So 10.5 plus 0.2 is 10.7 times 10. That just means I moved my decimal place, so 107. And if I give you units, you would say centimeters squared. That is the full extent of your test tomorrow. Please see me earlier in the morning if you have any questions. The earlier you get to school, the more questions I can answer and the more time that you will have individually. Good luck studying.